Welcome back to Java Internals Crashcasts. I'm Sheila, and with me, as always, is Victor. Today we're continuing our journey through the Concurrent collections season, focusing on CopyOnWrite collections. Specifically, we'll be diving into CopyOnWriteArraySet. Victor, before we begin, what should our listeners know to get the most out of this episode?
Great question, Sheila. Listeners should be familiar with basic Java collections, especially set interfaces, and have a general understanding of thread safety. It's also helpful if they're familiar with CopyOnWriteArrayList, which we covered in our previous episode.
Perfect. Let's kick things off with a quiz question for our listeners. Here's a tricky one. In a multi-threaded environment, which of the following set implementations is inherently thread-safe without external synchronization? HashSet, TreeSet, or CopyOnWriteArraySet?
Ooh, that's an interesting question, Sheila. It really makes you think about the nature of thread safety in Java collections. I'm curious to see how many of our listeners can get this right. It's not as straightforward as it might seem at first glance.
Indeed. We'll reveal the answer at the end of the episode. Now let's start with the basics. Victor, can you explain what CopyOnWriteArraySet is and why it was created?
Certainly. CopyOnWriteArraySet is a thread-safe variant of set that uses an internal CopyOnWriteArray list for all of its operations. It was created to provide a concurrent set implementation that's particularly useful in scenarios where read operations vastly outnumber write operations.
That's interesting. So it's built on top of CopyOnWriteArrayList? How does that affect its behavior?
Great question. Because it's backed by a CopyOnWriteArrayList, it inherits many of its characteristics. The most important one is the copy-on-write semantics. This means that any mutative operation, like add, remove, or clear, results in creating a new copy of the underlying array.
I see. So, if I understand correctly, this means that reads can happen very fast without needing any synchronization, right? But what about the write operations?
Exactly right, Sheila. Reads are indeed very fast and can happen concurrently without any synchronization. Write operations, on the other hand, are more expensive because they involve creating a new copy of the entire array. This is why CopyOnWriteArraySet is most suitable for read-heavy scenarios with infrequent modifications.
That makes sense. It reminds me of a collaborative whiteboard where everyone can read freely, but when someone wants to write, they make a copy, make changes, and then replace the original. Is that a fair analogy?
That's an excellent analogy, Sheila. It perfectly captures the essence of how CopyOnWriteArraySet works. Just like in your whiteboard example, readers always see a consistent view of the data, and writers don't block readers but pay the cost of making a full copy.
Thanks, Victor. Now let's dig a bit deeper. How does CopyOnWriteArraySet ensure that it behaves like a set, given that it's backed by a list?
Another great question. CopyOnWriteArraySet maintains the set contract by ensuring that no duplicate elements are added. When you try to add an element, it first checks if the element already exists in the backing array. If it does, the add operation is simply ignored, and the set remains unchanged.
I see. But doesn't that mean that add operations might be even more expensive than in CopyOnWriteArrayList, since you have to search the entire array before potentially adding an element?
You're absolutely right, Sheila. This is one of the trade-offs of using CopyOnWriteArraySet. Add operations are indeed more expensive because of this additional search. It's on to check for existence, and then another on to copy if the element is new. This reinforces why it's best suited for situations where reads greatly outnumber writes.
Got it. Can you give us an example of a real-world scenario where CopyOnWriteArraySet would be a good choice?
Certainly. One common use case is for maintaining a list of event listeners in an application. You typically add listeners at the start of the application and rarely remove them, but you iterate over the listeners frequently to notify them of events. CopyOnWriteArraySet is perfect for this because the reads, which are event notifications, are very frequent and uncontended, while writes, which are adding or removing listeners, are rare.
That's a helpful example, thanks. Now, what are some common pitfalls or misunderstandings developers might have when using CopyOnWriteArraySet?
One common mistake is using CopyOnWriteArraySet in write-heavy scenarios. The performance can degrade significantly if there are frequent modifications. Another pitfall is assuming that because it's thread-safe, compound operations are automatically atomic. For example, checking if an element exists and then adding it if it doesn't is not an atomic operation and can lead to race conditions if not properly synchronized.
Those are important points to keep in mind. As we wrap up, could you share some best practices for using CopyOnWriteArraySet?
Absolutely. First, use it primarily in read-heavy, write-rarely scenarios. Second, be mindful of the memory impact. Each write operation temporarily doubles the memory usage. Third, if you need to perform multiple updates, consider using the add-all or removal methods instead of individual add or remove calls to reduce the number of copies. Lastly, remember that while individual operations are thread-safe, compound operations may still need external synchronization.
Thank you, Victor. Those are valuable tips. Now let's reveal the answer to our quiz question. The thread-safe set implementation without external synchronization is CopyOnWriteArraySet. Neither hashset nor treeset are thread-safe by default.
Exactly right, Sheila. CopyOnWriteArraySet provides built-in thread safety, which sets it apart from traditional set implementations.
To summarize today's episode, CopyOnWriteArraySet is a thread-safe set implementation backed by CopyOnWriteArrayList. It excels in read-heavy scenarios but can be expensive for frequent writes due to its copy-on-write nature. It's great for use cases like event listener lists, but should be used cautiously in write-heavy situations.
That's a great summary, Sheila. In our next episode, we'll be moving on to the concurrent list implementations chapter, starting with concurrent linked queue. It's going to be an exciting dive into another crucial part of Java's concurrent collections.
I'm looking forward to it. Listeners, don't forget to subscribe to Java Internal's Crashcasts and leave us a rating if you're enjoying the series. Your support helps us reach more Java enthusiasts. Until next time, happy coding.